Okay, this is the P1 paper from January 2021. Question number 5. As you can see, it's a radians question, arc lengths and areas of sectors. Combined with those questions, quite often we have a triangle involved, so we can have cosine rule or sine rule. That's with this case is this question as well. So let's have a look at the question then. And it says, these radians questions are often, they're quite imaginative in the areas that they give us here. It can be the plan of a garden or a logo. In this case, this is a viewing platform. But even if they are still made up of our traditional shapes. I've got a sector here and I've got a triangle in there. So let's actually have a look and see what they're telling me in the question. And they've not put the information on the diagram, which they normally do. So let me put the information on the diagram. This is equal to 6 meters. This is equal to 6 meters. AD is 14 meters. ADC, this angle here, is 0.43. Right, I'm going to tick that. Don't miss out that bit there. Angle AOD is an obtuse angle. First time I did this question, I actually got the answer wrong because I wasn't concentrating on that bit there. OCD being a straight line, that's fine. That just tells me that it's a triangle in there. Right, what are they asking me to do? They're saying, can I find the size of angle AOD? AOD, that's this one here, that they've just said is obtuse. So what that means is that when I get the answer, it's got to be more than 90 degrees, or in radians, it's got to be more than pi over 2. So if I do the sine rule, I'm going to be doing the sine rule for this question. We've got to remember at the end that if I get the answer, for example, 60 degrees, it's 60 or 120, and I've got to take that one. I'll come back to that when we actually come and do this question. It's going to be the first thing that we do, but it can catch you out if you're not being really careful with this. Right, let's get started. So it says size of angle AOD in radians. So if I'm looking at this triangle here, okay, as soon as I've got a non-right angle triangle, it's cosine rule or sine rule. This one's the sine rule, and when it is the sine rule, I'm looking to pair things up. Okay, so I've got this side and this angle here, so that's good, that's what I want. And also I've got this angle and this side here. So yeah, I can get going with my sine rule, and that's going to work out to be able to work out what the asterisk thing is. Let's get rid of all those bits and pieces that aren't working. So AOD, I'm trying to find AOD. I can say, using the sine rule, sine A over A is equal to sine B over B. We're looking for an angle, so I always have the sine bits on the top there. I've got sine AOD. That one's working with the 14. That's paired up with the 14. Is equal to sine 0.43 over 6. And so sine AOD, the 14 can just go over the other side, can't it? 14 times sine 0.43, all divided by 6, in brackets, make it look neater. So sine AOD works out to be equal to 0.97. It's not the exact value. Use the exact value in your calculator, obviously, which means that AOD works out to be inverse sine of that. Make sure your calculator's in the radians mode, is 1.337. But this is where, and this caught me out just a minute ago, this is the second time of recording this video. Here it says that angle AOD is obtuse, okay? This angle is not obtuse, it's less than pi over 2, okay? If it's less than pi over 2, then what I've got to do is the actual angle I want, so obtuse AOD is going to be, you could say 180 minus it, but obviously we're working in radians. You should try and get used to working in radians and actually talk about pi and pi over 2. Works out to be that, which is 1.805. Would have been nice if they do this sometimes, if they'd actually said to me, show it's equal to 1.805, because then wouldn't have caught me out. But it did. This is the second time I've been doing this video because I got it wrong first time. So be really careful with that one there. But now we've got that angle is, that angle is going to be 1.805 radians. What do we need to do for part B? Part B says, can we work out the length of the arc AB in meters to 1 decimal place? ABC, sorry. There's the arc round there. Well, they won't catch me out with this thing. They never catch me out with this one when they're doing it. It's that angle there that I'm using as my theta, not the 1.805. So at least it can catch me out with part B. Part B here, if they want the length of the arc, that's just equal to r theta, which is equal to 6. But then the theta I'm going to use is 2 pi minus 1.805, okay? Stick that into your calculator. That comes out to be 26.9 meters with all of these questions. If I didn't do it at the start, I'll do it at the very, very end. Check that you've got them all to the correct accuracy. In this case, 1 decimal place for that one. And then part C says, calculate the total area of the viewing platform. That's going to be relatively straightforward as well. It's going to be the area of this sector, and then it's going to be the area of that triangle, just added together. When I'm doing the sector, remember, my angle will be that one round there, but when I'm doing my triangle, I'll be using 6. I'll be using 6, 14, and that angle in my half BC sine A. So that angle there is going to be 90, or rather pi over 2, minus 1.805 minus 0.43. Okay, so I'm going to be using half BC sine A, where I've got this one, and this one as my 2 sides in the angle. Okay, let's get on and do that then. So for part C, we'll do them separately. Area of sector, that's equal to half r squared theta. So that's equal to a half 6 squared, and then theta, remember, was my 2 pi minus 1.805. So work out what all that cancels out to be, calculates out to be. And that's 80.6. The area of the triangle is going to be half BC sine A, where my lengths are half, 6, 14, and then sine of that angle, which I'd say I'm going to put it in like this, pi minus the 0.43 minus the 1.805, and then I can stick that all into the calculator. So do sine of that, then times it by 14 and 6 and divide by that. That works out to be 33.1 square meters. So the total area, don't forget that at the end, total area is those two added together, 80.6 plus 33.1 works out to be 113.7 square meters. Get rid of that bit there and get rid of that bit there. Right, hopefully that makes sense for that last answer. Quite a tricky question, that one, so just be careful with it.